30 minutes of talking about emerging trend in tech. I know it's a lifetime is not sufficient, but we'll try to do 30 minutes. I am Jumana. I am a senior software engineer at Korea, a company that specializes in web monitoring and filtering. Along with being a software engineer, I am slightly known for being a stand-up comedian, a comic strip writer. So if you don't find my software engineering skills very impressive, still give me a shout. We have more things to talk about. Let's dive in. So today what we'll be talking about is some of the sections of tech industry. For each of the section, we'll try to dive a little bit into the history, what's going on, what's the newer trend in it, and what could be a potential business opportunity. Eventually, I'll give you some pointers on how to stay updated in modern world. This might get a little bit technical over the period, but take what you can and bear with me. So, these are essentially the sections which we will be covering. We will be talking about web development, about how it started and how it's going on, about machine learning and AI as if you haven't heard enough of it since morning. We'll also talk about embedded systems a little bit. And at the heart of all the system lies DevOps. What is DevOps is the process of how things in each of these sections should progress. So we'll talk a little bit about that. Now this, in no shape and manner, is an exhaustive list of all the sections of industry. You cannot rule out cybersecurity out of the picture. You cannot rule out enterprise system out of the picture. You cannot rule out Androids and app development out of the picture, but due to the time constraint, this is what we'll discuss today. So, web development. It all started in 1990s when Tim Berners-Lee decided to create a document sharing system within CERN. So he thought that let's create a document sharing system where people can just download the documents, and that gave birth to the concepts like HTTP, HTML, URIs, which we use till date. So if you hate web development, that is the person to hate. He gave birth to a very important concept called as client-server architecture, very widely known, still used. What is client-server architecture? It's just a request-response model. You make, as a client, you make a request to a server fulfills your request, and this entire communication happens via internet. There are a lot of advantages of this approach: centralized resources. Because server is a one-place affair, you can increase resources up there, and there you can manage it well, which ensures scalability. You can increase the computing power by just increasing the resources in the server side. Enhance security, single point, only one place needs to be secure, no client security is required. Efficient, yes, because you can extend the server. Although this sounds good, but there are a lot of limitations to the approach. First of all is latency. We all have seen that loading sign, right, that annoys us. So that is a limitation of this approach. Server overload, because the computation gets more and more complex, we need more and more things from the web world. The server overload happens, and security risk, because it is a single point of contact, it is a single point of failure. One thing crashes, everything crashes. So we thought, let's solve this one by one. So let's try and solve the first issue, that is server overload. This is my favorite series, so I had to create this one. So to solve this server overload problem, we came up with a design pattern. That design pattern helps us modularize the content in the server side of affairs, which we call as MVC, Model View Controller. How it helps us, it distributes the code into segments, which makes it more manageable. So there is a view, that is your UI, that is all the colors and all the display you see. There is a controller, which is the brain of it, which does all the processing, and it uses model to do all this processing. So model is basically a database blueprint. It interacts with it to get there. One of the early days web framework used for these were Ruby on the Rails, Django, and ASP.NET. You must have worked with them if you were in this. Now, this helps distribute server-side code a little bit. Now we are engineers, right? We want to progress. Now, when we thought we can apply MVC on the server side, let's make client-side a little bit more smart, and let's put MVC into there. So then we started putting MVC into client-side, which is now better known as single-page applications. What a single-page application is basically, it tries to give you an interactions you need to do, it just dynamically fetches them for you. So you can use Ajax and fetch to do this, so that you can dynamically talk to server and only fetch the content you need. How this happens is there is an initial load, so the browser loads all the HTML, CSS, JavaScript needed, which should be typically lightweight as per conceptual. The dynamic interaction happens, and the routing happens in the client side using virtual URLs. So you can use virtual URLs that will help you navigate through the process. So the key features, the things which SPA enable us is you don't see a full page reload, so you don't have to always refresh the entire page. There is asynchronous data loading, so that all the talking happens dynamically. Behind the scenes, there are APIs which are doing this for you. Client-side rendering, because client-side is becoming more and more smart, which leads to an enhanced user experience because you get an app-like experience. You don't have to keep that communication on. Despite this seems to be solving a lot of problems, there are a lot of challenges with this. The first one is the initial load time. Because JavaScript is involved in the initial load, it takes a lot of time to boot up. There are SEO challenges, search engine optimization. Now, because this is dynamically happening from the server side, whenever you search content, it's not statically available for search. So this is a massive problem, but there are solutions to this by using server-side renderings and static site generations. This we'll talk about later. Browser compatibility. Now, because we are using JavaScript in the front end, JavaScript updates really frequently. Because it's an open source, you can frequently update them, but the browsers are old. So there is an incompatibility issue that always happens here. So we use polyfills to fill that gap, but that is an issue. Security risk, because again JavaScript is involved in the front end, it is open to cross-site scripting attacks. That is a disadvantage. Although now it seems there are a lot of disadvantages, there are still places where it is used a lot. For example, in the websites which require dynamic user interactions, for example, dashboards, social media platforms, where you continuously interact with the website for higher user engagement when the users need to talk about. Offline functionality, SPA can give you caching type of offline functionalities because a lot of things are already loaded. Some of the good examples that are used today would be Gmail. Now, when you initially load Gmail and when you're going through each and every emails there, you don't need to go for a full page reload. Google Maps. So when you search in Google Maps, you zoom in, you zoom out, you search again, you never have to go through entire page reloads. That is completely built in SPA. Facebook and Twitter, so social media platforms, because you are scrolling and clicking links, it doesn't generally load the entire screen again. So these are the applications of single page application. So this is what has already been there. Now let's talk about what's coming next, or what are the newer trends in this segment. Please get it next slide. Cool. So let's talk about the newer trends in technology. So one of the newest buzzword here is progressive web application. What it does is it is the best of both the worlds. It is the best of website world and the application world. So Twitter, likes, Starbucks, Pinterest are some of the common examples of it. It gives you a better performance on slow network, which is a disadvantage of single page applications. There is server-side rendering and hybrid frameworks, this we already talked about. It helps you with search engine optimization. So the thing is that rendering is not only client-side but also server-side. Now based on your application's usage, you can divide this code to have, like this functions could be server-side rendering because you can manage a little bit of slowness into this needs to be client-side, you can manage this. So this gives us the power of controlling how much time every process takes to execute. This massively helps your application to behave. You get more control of basically what you're doing. We love that. Micro frontends, absolutely must have. I'm using this at the moment. So what this does is modularizes different chunks of code. Each team can independently work on one micro frontend in a completely different language. And it offers a tight coupling between those components. So it becomes really, really well manageable, reusable, scalable, and if you want to change something, you just need to remove one chunk of code and you don't have to run the entire integration test to prove it. So some of the tools used for that is single SPA, Tailor, module not buying a bed, it starts listening to pillows before bed sheets. Does that make sense? Predictive analytics dashboard. So, predictive analytics dashboard, I think will revolutionize the monitoring world, because right now, when we do dashboarding, it's after the incident has happened, we get the results, and we make an analysis, this went wrong. Predictive is when you can predict it ahead of the time that this is misfortune that can happen. That can save us a lot of money, effort, time. Must have. This is it. That was all about, I had to talk about web development. Let's move to the next section. Don't worry, not everything of that would be so long. I am originally an embedded software developer, so I'm very much passionate about what's going on in the embedded world. I know Oppenheimer-Barbie rivalry is over, but this just makes sense. This just makes sense. So, what is embedded systems? It is the dedicated systems within the large systems to perform a specific task which requires hardware, which requires you to talk with hardware. Slowly things might move to cloud, but we still require hardware in a lot of systems. How did it all start? In early days, there was a language called assembly language. Anyone who has worked with it will know that life was really simple during them. You talk in machine language and there's like MUX and 029 and 290. So you're literally talking in memory addresses to the hardware. It is so quick. Just everything happens in a flash. I would like to go back to that days, but it is not practical, right? You cannot do much out of it. In those days, you can just make like a calculator or a traffic lights. That was basically what assembly language was used for. In embedded world, the revolution of 70s and 80s is very important because C and C++ entered the world. Now C is still the largest used language in the embedded world, and it would be next to impossible to completely eradicate it because even the higher language library are using this under the hood. C++ are magical, they are readable. Still they are very close to hardware, gives them very high computation power. They are really fast. C++ introduces you to object-oriented programming as a concept, which is used for more complex systems like automobile, infotainment. Even today, entire automobile industry, equipment, train equipment, still use C++. C++ has a larger memory footprint than C, but it gives you a richer library set. That's how we progressed. Talking about what's going on now. So today in embedded world, the new languages have come up, Rust and beyond. So Rust, Golang, these have overruled all the limitation of C and C++. Not all, but most of them. So if you get an opportunity to learn them, or if you want to stay updated, it would be good to invest some time in that. C and C++, although seems very important and will stay, it has a lot of disadvantages. For example, you require language memory management into C++. In Rust, it follows a borrowing references principle. So there is either one mutable reference or there is a lot of immutable reference. So memory leaks just never happen. Buffer overflow is a lot of problem in C++. So those who have worked with it know you always get an index array out of bounds no matter what you do. That is not happening in Rust. Rust avoids garbage collection, which makes it fast. Despite that, using strict compiler checks, it's delivering the same performance. It is more readable, it is more verbose than C++. It uses ownerships and borrowing rules where the databases are called. So C is not thread safe. You know the idea that there is a multiple threads which work concurrently. To give you an idea of concurrency, that is, it is not thread safe in C++. Databases can happen, you can be into a race condition loop. That never happens with Rust. So embedded system, you have to stay updated. Golang is also doing really well in this field because Google has created Golang and it has written the entire Kubernetes in Golang. It is adapting it in most of its services. So these are the indicators that these will stay long, right? So it is worth investing time into that. When I talk about business opportunity, Internet of Things just stays in the mind because we want smart systems. Now what Internet of Things basically is a concept is that you link devices to the cloud world and then you create an entire ecosystem where your data keeps being opportunities you'll get out of it. So invest some time into that. We will discuss about a little bit about the technical aspects of machine learning and artificial intelligence. I know we've talked about this a lot since morning, but you can't escape it, right? ChatGPT was not used in making this presentation. If I say that, it would be a lie, but there's no rule of not lying on stage, right? So, okay. Anyway, this picture just makes a lot of sense because I really believe that Python and maths is what is keeping it all together. It's the root of how deep learning happens. On the land of UK, if you talk about artificial intelligence, you cannot not mention Alan Turing. So Alan Turing is the guy who came up ever with the idea that can machines think. So that's called the Turing test. Turing test is not a framework or not checks. It's just a concept which asks you the basic question that can machines think. So that test is just like you take answers from a machine, you take answers from the human, how much they match, that is what you achieve with that machine. Alan Turing is cremated not far from London. It is a place called Woking. If you get a chance to read his biography, interesting work done by him during World War II, amazing stuff. So that is the first of the idea, the birth of the idea of artificial intelligence according to him. Now when we talk about early AI, it is symbolic AI and based systems. It uses Lisp prolog. This can be as simple. So this is like creating a theorem, solving algorithm, or proving something. So that is what early AI was about. For example, TikTok solver is a good example of that. We then move to statistical AI. What is statistical AI this is where data has entered into the system. This is where data has entered into the machine learning world. And because of a lot of data, we start creating linear regressions, which gives us statistical analysis of a thing. So, for example, a storm analyzer could be a good example. A spam filter could be a good example. So, because you have a lot of data, you recognize that these are the things which could mean that you are doing something else. So, this creates an SQL algorithms. That means that you outline data, so you start segregating data, that grouping of data, that helps in the machine learning a lot. Then comes modern AI. Modern AI introduces deep learning. So in modern AI, Python is the root of deep learning. So you will understand why we use Python in these things, because Python is very simple to read. You don't even need algorithms in Python because it is that easy to read. So it is an interpreted language, so it goes line by line by line. And when it gets started in complexity, you have to enter C++ into the system. When we talk about modern AI, good examples would be Amazon recommendations, CD, Netflix, resource intensive things basically. Then comes generative AI. Generative AI is what we use today. It's highly used, known everywhere, everybody knows what. The best example of it is ChatGPT. ChatGPT is the large language model system in the world. So ChatGPT is entirely built on PyTorch framework. PyTorch is a framework which Python gives, which is primarily built in Python and a little bit of C++. The thing with Python is also the rich set of libraries. It has intensive set of libraries. Think about the thing you want your code to do, and Python must have a library for it. I have tried this exercise so many times, I've always failed. I would like to succeed once. Anyway, this sounds very revolutionary. It is revolutionary. But there are some disadvantages to generative AI at this point. There is a lot of ethical concerns to it, data bias and misuse of it. I have done an entire panel discussion on data bias. It is available on my website. So give it a check if you are more concerned about this. And it requires a lot of environmental resources, so it is resource intensive. What would come next is, I would say, cross-language ecosystem. So because we have more languages which can do faster things, so you can use them along with, so you can use, for example, Rust along with Python and create something which makes sense and also works faster. Things like that. Ethical AI is something we are looking forward to. Efficient AI in terms of energy efficiency. Quantum AI, when you do quantum computing in AI research, that is something that's coming next. If I talk about business opportunities in generative AI, there is a lot of it. Any app you open, you can customize it to as per the person who's opening it. For example, if you're opening a video editing, things that they like could be recommended. And this is happening as well. So you don't think about whatever you do, you can customize it as per user into in your career. DevOps just goes along with it. Learn to live with these if you want your life to be slightly simple. So use version controls. I have mentioned the tools you should use. Use CI/CD pipelines, continuous integration, continuous deployment. As soon as you're building something, try and deploy something so that you don't have to wait for ages for you have an answer if this really works. Infrastructure automation, it helps resource management to another level because it will even make it mutable. One person only accesses it at one time, reducing all the confusions. Containerization and orchestration, again, I've done one more seminar on this. This is beautiful as a topic, gives you modularization to a next level, aiding you to work in chunks